Welcome everyone to the 6th online seminar in this Marine Biosecurity series, which is hosted by the top of the South Marine Biosecurity Partnership and the top of the North Marine Biosecurity Partnership, who are working together to help stop the spread of marine pests. These seminars have been really well supported so far. They are recorded and you'll be able to check in and forward a link to your colleagues that you'll receive after the completion of the seminar. So nearly a year ago, a pair of fishermen who happened to be ecologists working for Auckland Council discovered an invasive species while they were on a fishing trip at Great Barrier Island. It was a pretty shocking, sad discovery, and today we're going to hear from staff at Biosecurity New Zealand and NIWA about the huge amount of work that has gone on since that day to not only limit the spread of Caulerpa, but also to investigate any ways to possibly treat it and keep it at bay. Our speakers today are Jess Russell, who is the Response Manager at Biosecurity New Zealand, and also Dr. Graham Ingalls, who's Chief Science Advisor, Group Manager and Program Leader at NIWA. We aim for the seminar to be finished by midday. Please just keep your microphones muted if you can, and if you wish to ask a question, you can raise your hand, mention your name and organisation if you can, or just pop a question into chat and I'll address it. Thank you. I will hand over to Jess.
Kia ora koutou katoa. Hi everybody. So ko Jess toku ingoa ko te ora matara te akitanga pūteo o te roa toku mahi ana. So my name is Jess Russell. I am, as Zoe pointed out, a response manager here at Biosecurity New Zealand within the Readiness and Response Directorate. And I've been the response manager on the Caulerpa response for BNZ for since December 2021. So we're just going to take you through today some of the background of what we've been doing with the Caulerpa response, some background of what we've been doing, what we're planning to do in the future, and then also how you can help. So there are some things that we would love you guys to get involved with, particularly within the pathway management space. So we'll take you through that. I am aware that when we present on Zoom, I won't necessarily be able to see the hands. So Zoe, if there is a question, if you can just stop me and I'll answer the question. Any questions to start before I jump into the presentation? Awesome. Okay, cool.
There's someone there I'd like to ask if they can mute, if that's possible, please. I can just hear some noise in the background.
Awesome. In which case, I will just share my screen if I can make it work. Host disable participant screen sharing, Zoe.
That is not true. Try now.
Awesome. I will also just introduce, so Zoe did mention that Graham Ingalls is here, so he's from NIWA, and also I think Roberta Darcino is also present today. So NIWA have been pretty much our eyes and ears on the ground or in the water for this response, and they've got some really great information in terms of what it actually looks like to see Caulerpa in the water. So any technical questions in terms of identification, I'll probably hand over to NIWA to answer. But now I can share my screen. So you should be able to see a screen now. Yep, awesome, cool. So exotic Caulerpa, the next big marine biosecurity threat is the title of the presentation today. So we'll take you through some of the impacts of Caulerpa and yes, what we've been doing to date. So this image is a really great image that was captured by NIWA in their survey of Blind Bay, and I'll take you through that shortly. But as you can see, it's a bit of a carpet there. So this is what we're hoping to avoid elsewhere where Caulerpa has been found and also prevent it spreading. So it's a bit of an impactful picture. So on the agenda today, we'll take you through the discovery of Caulerpa, what is exotic Caulerpa and the species that we're dealing with in New Zealand, the response to Caulerpa, the treatment trials that we've been doing, ongoing surveillance, and then what you can do to help, and then happy to answer any questions. So hopefully we should be done before 12. If we're not, I've been talking for far too long. So as Zoe mentioned, in early July 2021, a local ecologist that I believe was working for Auckland Council, who was living on Great Barrier at the time on Aotea, posted a picture of an unusual looking algae on iNaturalist. So just to give a bit of a perspective, we've got Auckland Central here on this map, and just up here, and I hope I can move that. Just up here is Great Barrier Island or Aotea. And they posted this unusual looking algae from a location called Blind Bay, which is just where this little image is circled.
Jess, you may not realise Jack's actually here today. He's watching.
Oh, wonderful.
Yeah.
Oh, that's awesome. So thank you so much, Jack. Really appreciated. And this image here is of Blind Bay, a beautiful location on Aotea. And the picture was this fella. So really good, clear image uploaded to iNaturalist, which was then identified from NIWA and also our marine biosecurity teams as highlighted as being probably not a native Caulerpa and something that people had not seen before. So this was then identified as Caulerpa brachypus via visual and molecular methodologies, both at MPI and then molecular at NIWA. And this is a new to New Zealand species. So based on this, we decided that a delimiting survey needed to be conducted in Blind Bay just to understand the extent of what the Caulerpa infestation was and what we were going to be dealing with. So this survey and all of our surveys to date have been undertaken by the National Institute of Water and Atmospheric Research, that is NIWA. And what they found, unfortunately, in this August survey was that the infestation in Blind Bay was extensive. So it covered approximately 88 hectares, so that's a huge piece of space that is covered almost completely. So as you can see here, all of these red dots are locations where delimiting transects were undertaken in Blind Bay. All of the red ones are positive, so Caulerpa was identified, and the green ones are areas where at that point Caulerpa was not identified. Just to also be clear, we do have native species of Caulerpa in New Zealand, and when we refer to Caulerpa in this case, unless specified otherwise, we are talking about one of the invasive species that we're working with. So Caulerpa brachypus was found up to a depth of 30 metres in this survey, and then subsequently has been found at depths of up to 38 metres. And it sort of looks like a dense carpet over the seafloor in Blind Bay. A second species has also been identified of Caulerpa, which is called Caulerpa parvifolia. This is almost identical to C. brachypus. And just to give you a really good idea of what we're talking about in terms of the extent, I've got a little video that I'll just show you some glimpse. As you can see here, oh, the internet is struggling. Oh dear, a bit buffery, sorry guys. But as you can see, for this very slow video, we've got a huge amount of Caulerpa covering Blind Bay and the seafloor. I'll also share the link so that is attached on the PowerPoint and is also available on Facebook from the Great Barrier Island Local Board page. But as you can see, this is from a snorkel dive, and Caulerpa is just everywhere. I think we are unfortunately going to have some buffering issues. But it should give you a good overview of the level of Caulerpa that we're dealing with in Blind Bay. So it's like a carpet, it covers pretty much anything, rocks, sand, silt. It grows on top of shellfish, including horse mussels and scallops, and a number of other substrates. So it's not overly specific. I will send out a link to this video just because we are having some buffering issues, and I'll move on, but it should give you a good indication of the density of Caulerpa that we're dealing with in Blind Bay. So I guess the question now is, so what is it? You know, so we've worked out that we've got this massive infestation in Blind Bay of this new seaweed, but what are they? So at the moment we have detected these species on Aotea Great Barrier, and then later on Ahu Great Mercury Island. So Blind Bay has been the first place that it has been located. Following that, we have subsequently detected it in Tryphena Harbour and Whangaparapara Harbour on Great Barrier Island. Caulerpa is a genus of seaweed species that are native to the Indo-Pacific region. They can now be found from Africa to Australia, the Pacific Islands, and southern Japan. These particular species have been found in Florida as invasive species where they've had impacts to a number of different native species biodiversity and abundances. So some negative impacts that we don't want to see happen in New Zealand. This is to say, though, that it's not to be confused with Caulerpa taxifolia, which you may have heard of. Caulerpa taxifolia looks like this. So it's branching, so quite different from that picture above, where you can see that there are individual leaves that don't have a number of these small fronds coming off the central midrib. And Caulerpa taxifolia, you may have heard of it, it's one of our most unwanted marine algal species that we don't want in New Zealand. So it's not to be confused, but it is in the same family, so not Caulerpa taxifolia. How does it spread? So this is the problem with Caulerpa, is that it can spread through fragmentation. So that means if you break a bit off, whether it's through wave action or moving gear through it, it can break off, travel somewhere else, and then if it lands on appropriate substrate, which is a number of varieties of the substrate, it can then settle and establish. So this is a really big issue when moving through Caulerpa beds, like those big sort of carpets that you saw, especially with anchors or fishing gear. So what we don't want is people being able to accidentally move Caulerpa through getting it stuck on their anchor, pulling it on board, and then moving it elsewhere. So fragments can survive out of the water for up to 7 to 10 days if they're in a moist location. So it's really easy for people to accidentally cause jump spread of Caulerpa from one location to another without even knowing that they have spread it by accident. On a local level, fragments can also be carried easily on coastal currents, and this tends to move it within that sort of same current area, but it does mean that it can move. What you've got on the right here is a picture of what we call beach cast. So this is a big chunk of Caulerpa from Blind Bay that after a storm has washed up. It's been ripped from the floor of the ocean floor and washed up onto the beach. So we can get these massive chunks of it. And as you can see, it still looks a little bit like a carpet. The potential for the rest of New Zealand to get infested with Caulerpa is limited to the top of the North Island within the sort of blue area here. So climate limitations of these species based on lab studies tend to correlate with an average winter mean ocean temperature of approximately 15 degrees. So what that means for those who don't quite understand is that on this image up on the right, this colourful one, you can see that we've got a number of different isotherms. So in a winter average temperature, so averaged over a number of days throughout the winter period, we've got the average ocean temperature. So this dark line here indicates 15 degrees. So the temperature gets to a mean of 15 degrees, and that tends to be the cold tolerance of Caulerpa. So that tends to correlate, unfortunately, with most of the east coast of the upper North Island. It's also been found to grow, as mentioned, at depths up to 38 metres in Blind Bay. And so it's quite deep, and it can actually survive for quite warm weather. So what we've done is some really basic mapping, which you can see on this blue and white map here. So this is an indicative image of the different areas that Caulerpa has the potential to establish in New Zealand based on only temperature and depth. Of course, there are other things that will impact the likelihood of Caulerpa establishment, and that includes nutrient runoff, wave action, the substrate as well. But in general, these areas are considered the highest risk. And more than that, any area within this blue section that has high levels of anchorage or vessel traffic are considered to be very high risk. So if Caulerpa was going to establish here, these are the places that boats are most likely to go to. So high popularity anchorage points. And as you can see, unfortunately, that shallower part of the Hauraki Gulf is very much in there. And you can see here, due to this sort of shallow area through here just next to Great Mercury Island, this is a high risk zone as well. So the Caulerpa response was started up in August 2021 with a number of key objectives. So the first one is to reduce the potential risk of Caulerpa spreading around Great Barrier Island, but then also throughout wider Aotearoa. We want to minimise the potential impacts to the environment, communities and visitors to those places. And moreover, we want to enhance the mana of mana whenua and ahikaroa and all partners in the response. So for the Aotea portion of the response, a governance group was set up in partnership with Ngāti Rehu Ngāhi Wai Ki Aotea, Auckland Council, DOC and Biosecurity New Zealand. And it's all shared decision making there. And we've also established, and I'll talk you through a little bit, the Great Mercury Island section of the response as well. But I'll just take you through some of the actions that we've done to date within the Caulerpa response, mainly focused on Great Barrier Island. So in order to reduce the spread of Caulerpa outside of the known infested areas, which you can see on the right-hand side here, this is a map of Great Barrier Island or Aotea, and you can see here the red spots are all of the different positives that we found and where we found Caulerpa. And the green spots are indicative of areas that have been searched where Caulerpa has not been detected. You'll see that there are a number of shapes, and each of those shapes represent a different survey that NIWA has conducted for us, which has been really, really great. So a number of surveys over a number of months, which gives us a really good resolution of where on Aotea at the moment Caulerpa is. So we've got Blind Bay, as mentioned earlier, Whangaparapara Harbour and Tryphena Harbour. So in order to reduce the likelihood of Caulerpa moving outside of these areas, we've placed controlled area notices for these three areas on Aotea, and that is section 130 of the Biosecurity Act. The controlled area has a number of restrictions, and within those controlled area zones, which is highlighted in this red shading here, you cannot collect any kaimoana. So that includes shellfish, fish, lobsters, crays, anything like that. You also can't bring a vessel into the zone with the intention to collect kaimoana. This has been reinforced by Arahui, by mana whenua on the island, and also promotes and is additional to the wider Ngāti Wai and Ngāti Hei rahuis against scallop collecting at all in the Hauraki Gulf. All equipment within the controlled area must be cleaned prior to leaving the zone, and any boat that anchors within the zone must get a permit and provide evidence that they have cleaned their anchor prior to leaving the zone. So this gives us confidence that we know that people who are entering the zone are going to, if they accidentally get Caulerpa caught in any equipment, will have cleaned their equipment before they leave the zone. So it reduces the likelihood of Caulerpa moving outside of these can zones. We're working with the locals on Aotea, so we've got an ambassador program with Aotea that promotes education and providing additional information to visitors on the island, as well as an on-water compliance program using a number of local boats and local skippers who can just do some monitoring and ensure that people who are anchoring have a permit and that they are aware that they need to follow the requirements of the can. We have also put a can in on Great Mercury Island, so Ahu Ahu, and I'll take you through that in a moment. But these cans have had really good uptake. The locals have been really good at promoting it to visitors, and we are, as not very surprising, as it gets colder, we're having fewer and fewer visitors to Aotea Great Barrier, which means that the risk level has reduced slightly as we go into winter. So we've done further delimiting as explained. So as you can see, we did from Blind Bay, we then checked it out in Whangaparapara and Tryphena Harbour where it was found. At this stage in September when we did these surveys, we found very small quantities of Caulerpa. So we're talking about maybe 10 metres squared, about 1 metre squared in the respective bays. And when we compare that to the size of the outbreak in Blind Bay, where we had 88 hectares, so that's 880,000 metres squared. These are very, very small amounts. And what that looks like is kind of like this. So it's really hard to see, but this is an example of how difficult it can be to see Caulerpa on the ground. So amazing work from NIWA to have absolutely sharp eyes to detect this. But as you can see, this little green stuff in here, this is a very small little fragmented patch of Caulerpa. Given that the size of the amount of Caulerpa in these bays in September was 10 meters squared and a meter squared-ish, we worked out that it's probably small enough that we can actually do something about it. So we pulled together a technical advisory group. So the technical advisory group was made up of a number of ecologists, marine scientists, researchers, algal eradication experts, and Mātauranga Māori specialists, who all met in October 2021 to work through some options of what would be the best way to get rid of Caulerpa and what were the tools that we should be using. The TAG determined that the blind bay population was beyond eradication at 880 hectares. There are no tools available that would be able to cover that much ground, and also anything that was available would have severe environmental impacts. So 9 tools were assessed by the TAG, and coarse salt was determined to be the most effective tool to be scaled up for a potential treatment. This would be at a rate of 50 kgs per meter squared. That should have a little 2 on it, per meter squared. So even in a small amount of area still requires a huge amount of salt. So just got a little image here just so you can see the difference. So coarse salt, we've got table salt on the left, kosher salt in the middle, and then coarse sea salt. So that's about 4 millimeters in grade. That's the sort of level of salt that we need. So it would need to be quite in bulk. So in December 2021, NIWA returned to treat and kill the Caulerpa and whangaparapara in triphenas, and they brought enough salt to treat 24 meters squared, which was way more salt than was required at the time. So if you remember in September, the amounts were sort of 10 meters squared and 1 meter squared. So 24 meters squared worth of salt is plenty. However, when they returned to the same place to treat it, they found that the Caulerpa populations had exploded. So over that period between end of September and early December, Caulerpa had jumped up to about 2,000 meters squared in each bay. So it's quite a lot bigger. And here is a video. If I move this, oh my goodness, how do I move this? Okay, so this is a great video that's not wanting to play, so having some technical issues. That is really annoying. Sorry, team. Effectively, this just showed, and I'll send you through links afterwards of the videos of NIWA placing down quadrat sizes in the area, which was really awesome to see the extent of Caulerpa and how they went about doing this all underwater. Cool. And then the salt was applied at a rate of 50 kilos per meter squared. So because the amount of Caulerpa was much larger than the expected amount, a decision was made between the response and NIWA to do a trial salt treatment in the area. So salt is often known to be a really good treatment tool for algal pests, but we didn't necessarily know too much about how that would work with Caulerpa. Based on technical advice, it was likely to be successful, but we needed to check. So salt was applied at a rate of 50 kilos per meter squared as required in 2 different 12-meter squared trials. So one in Trifina and one in Whangaparapara. So this is another video which I have a feeling is not going to work, which is a little bit frustrating. But NIWA was able to use a hopper and a pipe system to deliver salt down to construction divers through sort of like a tube, you could say, from the boat, and have a construction diver place it down and do some quality control to ensure that the salt came down through the tubing and hit the floor, the sea floor, where it needed to go within that quadrated area. Hessian matting was then applied and pegged down using rebar pegs, and the treatment plot was covered with tarpaulin on top of the hessian, which was removed 24 hours later, and just to ensure that the salinity level of the treatment plot was maintained and at a high enough level that it would kill the Caulerpa. So NEWA have been returned every month in order to determine the efficacy and impacts of the salt treatment, and also to monitor Caulerpa regrowth. So scorched earth was sort of seen under the hessian, which was expected, but it does mean that it is, as we expect, to be non-specific. So on the right-hand side here, this is inside the treatment area within Trifina. So as you can see, previously there was a whole lot of Caulerpa, and this is underneath the hessian. It is just completely barren. So that means that anything that was there that might have been native has also died, but it does show that outside of the treatment area there is no ongoing effect or any effect where the salt does not contact. So that is good news. However, Caulerpa did grow back on top of the hessian. That being said, just note that the Caulerpa was high density, and we did the trial in the centre of a high density area. So hessian ends up being quite a good substrate for Caulerpa to grow on top of. So it's not unexpected. And when the hessian was removed, exotic Caulerpa did re-invade the empty patch, which again is what would be expected, just because we're doing it in the middle of a high density area. In order to understand the impact of the salt, an experiment was conducted using core sampling. So pre-treatment, a day before the salt was applied, NEWA took some cores where they were about 13 centimetres deep by 10 centimetres, so sort of indicated like this, and they took cores there, and there's a number of natural diversity within there, the different cores, and in pre-treatment, a high number of taxa and individuals were present, as would it be expected. In a day post-treatment, there was no obvious difference in species richness or abundance. So here we have some nice little drawings of what it looks like. So high diversity covered here, and then 30 days post-treatment, final cores were taken that have been evaluated since, and there was a significant reduction in both abundance and species richness. So obviously, and it is expected, that salt had a clear negative impact on benthic macroflora. So we're talking about tube worms, macroflora and fauna that lived in the substrate. However, the impact is expected to be temporary. So in the Australian context, where they removed or are attempting eradication of Caulerpa taxifolia, they found that it took about 6 months at the minimum for biodiversity to return to that area. So we are just aware that in terms of salt treatment in anywhere moving forward, that if we are using these intense amounts of salt, so 50 kilos per metre squared on, hundreds of thousands of metres squared, there will be an impacted benthic macroflora and fauna. So just wanting to make people aware that we are aware of the impacts of any treatment that we do. So we have some ongoing surveillance that has been happening. So as mentioned, NEWA have been going back to Aotea pretty much every month since December, which has been really awesome. So between 18th and the 20th of March 2022, so it's this year, NEWA went back again to Whangaparapara and Trifina and used a new methodology. So previously we had been undertaking these surveillance trips using transects and specific dive requirements within those transects. For this trip, they use a new star transect methodology. So this is to determine the outer boundaries of a population and work out the population density of exotic Caulerpa in these harbours. So what that looks like is getting a sort of starting point where you've got a really high level of Caulerpa and going out at a 45-degree star for 100 metres. If you get to the end of that 100 metres and there is Caulerpa present, you go out another 50, and if it's still present, you go out another 50, and so on. In the event that Caulerpa is not present at that end of the 50 metres, the divers would swim backwards in order to characterise how far along that 50 metres Caulerpa is present. And what you end up with is a really good understanding of the footprint of Caulerpa in an area. So if you remember, Caulerpa, when we went back in December to do the treatment, was estimated to be about 2,000 metres squared, and that was using those transect detection methods. But using this new methodology, NEWA was able to identify that the minimum size of the hotspots areas surveyed were up to 5,000 metres squared for Whangaparapara Harbour for one hotspot, and 22,000 metres squared for Tryphena Harbour. So that's Whangaparapara and Tryphena. And what that looks like is like this. So these are some really cool maps that have been designed. And as you can see, this is on the left for Tryphena. So again, we've got the initial hotspot here, high density. These are heat maps. So up the top here is our little key. So you've got sparse, anything from sort of this light blue outline is looking at about 0 to 5% coverage, all the way down to over 95% coverage in that bright yellow section in the middle. The positive transects where we found Caulerpa in these areas are identified here, and the hotspot is taken from sort of a high density area of one single positive transect. So what you end up seeing is this big Nickelodeon looking splodge here, where the divers have gone out 45 degrees from the central area and been able to determine the footprint. And again, you can see here in Whangaparapara, we've got 2 hotspots where the divers have gone out from, and you can see 2 really high density sort of arms coming out here. We've also gone just over here in Rapid Bay. Niwa has just completed some dives of doing a hotspot sort of star methodology dive here too, and we're just doing some calculations around what the footprint of that is. But we would expect that this is the minimum size, unfortunately. So if we were to repeat this activity on all of the positive transects, it's likely that Caulerpa is going to cover, the whole area. So unfortunately, it has been deemed that given the amount of salt that would be required, that it's unlikely that treatment is feasible in either of these locations, given that the footprint size, the amount of salt and the environmental damage, not to mention as we would have to go through, and it's something that we're working on in the background anyway, is resource consent and EPA approval to put this much salt in the ocean in the event that it was deemed feasible. We've also done surveillance elsewhere. So obviously we know that Caulerpa is present on Great Barrier Island, which is over here, but we want to know what are the other sort of high risk sites and other places that we probably need to be aware of. So Niwa undertook over 50 dives in a variety of high risk sites. These are all on the map here, and no Caulerpa was detected in any of these locations. And that includes Sandspit, Bonacord Harbour, Maharangi Harbour, Omaha Cove, a number of areas on Waiheke Island, Half Moon Bay, Islington Bay, etc. So lots of different places that have a high level of anchorage, and nothing was detected there, which is really good news. What we did find, however, is a second detection of Caulerpa on Great Mercury Island, in March 2022. Sorry, guys. So Niwa used this star transect methodology and determined, unfortunately, that the Caulerpa extent on Great Mercury Island is about 32,000 metres squared. So unfortunately, again, too large to put tarps to cover or to treat with salt. And those locations can be found here. So this is Great Mercury Island, an absolutely gorgeous spot, and it's in that western bay. A controlled area notice that has pretty much the same requirements of the other zones has been established across this bay here. And if you do need any information on the can, we have a whole lot of information on our website. And I'd be happy to take questions after this on any questions you might have for either can. We also set up a second governance group with members from Biosecurity New Zealand and the local Great Mercury Island representatives. So that includes Ngāti Hei as mana whenua, Waikato Council, the Department of Conservation, the local board, and also the private owners. So Ahu Great Mercury Island is privately owned, but it is managed in partnership with the Department of Conservation. So a number of people go there for day trips, especially coming from Coromandel, and people often anchor in these bays, and it's often a really popular sport fishing location. So the can, we're hoping again, will reduce the likelihood of Caulerpa spreading from down here out elsewhere. And we've got some really good uptake from the private owners and also Ngāti Hei, who are doing a lot of work at the moment to get that message out to local communities in the Coromandel. So really positive. So what can you guys do to help? So pathway management is key for the management of Caulerpa for where we are now. So obviously in the locations where we found it, it is unfortunately the population is too large to treat. That doesn't mean that we can't treat new locations if they come up and they are small enough, but we do need to make sure that that is feasible, especially given Caulerpa can grow at such a fast rate. So the biggest thing that you can do is to ensure that you're cleaning your anchor and chain and all equipment that you are putting in the water before moving on. So if you find that you pull your anchor up and there is Caulerpa stuck to it, or any other seaweed or any other life form, just make sure that you are removing that and dropping it back where you found it before you move out of wherever you are. We are also doing 2 community hulis, so one on Aotea on the 17th of May and one in Whirianga on the 28th of May, where the communities will be more than welcome to ask questions and just get a bit of a summary of what they can do to help specifically too. We also have a stakeholder updated mailing list, so we do stakeholder updates pretty often, and if you are curious, just send me a message and I'm happy to add you to the stakeholder newsletter. And also to just be aware of what Caulerpa looks like. So here you've got sort of 3 images of what Caulerpa looks like and how small and little it can look when you first see it to what those sort of carpets look like. So what we're hoping to do is find Caulerpa when it's at this size. And we've got more information on our website with some fact sheets and pamphlets around what to be on the lookout for. So if you do find it, please take a picture. That's really, really important to being able to identify it. And what we would need is for you to call the Pest and Disease hotline on 0800 80 99 66 or to report it online. MPI has a great new online reporting tool for those that don't necessarily like getting on the phone. And the link is just there and we can send that out to you guys as well. And that's a bit of a summary on Caulerpa, brachypus and parvifolia as part of the exotic Caulerpa response being run out of Biosecurity New Zealand in partnership with Auckland Council and the Department of Conservation, local councils in Waikato and Auckland, and mana whenua from both sites. So yeah, that's pretty much it. And if you have any questions, I am happy to take them. And I'll try and stop sharing my screen now. Okay.
Thank you, Jess. I saw there was a question come through on chat from Chloe. Just says, how do you clean your equipment? Where do you clean it? And in the water at that location or on land?
Yep. So we would prefer if it's to do with your anchor, that it's just even in the water where you are, as long as it's in the same location as when you dropped it. So obviously you might drift a tiny bit, but if you can keep it within that region, that's awesome. Previously the can had specified to use clean water. If you have clean water available, that is preferable. It's more likely to negatively impact the biology of the seaweed. However, if you don't have adequate fresh water, using salt water is fine as well, as long as it's off your anchor and you're not going to spread it elsewhere. If you are going to be using equipment that's not an anchor or chain, sort of topside gear, but things like if you're using kayaks, wetsuits, anywhere, if you find that there's stuff on it, if you can please rinse it with fresh water on land, and preferably if you can to dry the equipment 100% before you use it again. Some cases this might not be practicable, but where possible, that would be awesome.
Great. Any other questions? Put your hand up or unmute yourselves and speak up. Barry, you'll just need to unmute yourself, Barry.
Good day, Barry Forrest here. So I'm based in Nelson and work with the Top of the South Marine Biosecurity Partnership. I guess, you know, one of our interests in Caulerpa has been whether we might see it in these parts. And I'm really keen to hear about the level of confidence that you have in that assessment, that I guess it was based on lab studies, you said, that the New Zealand distribution is likely to be confined to that upper northeast area. And whether, I guess, whether there are any other ways that you might get to, any other studies you might have planned to better understand what that distribution might be.
Yeah, that's a really good question. So what we are faced with at the moment is a number of information gaps. So Caulerpa, obviously, these two species have never been found in New Zealand. This is actually one of the coldest places that these two species have been found. So we're not really sure of the tolerances within New Zealand, within that marine environment here. So unfortunately, it is based at the moment on existing lab studies at that 15-degree isotherm. Based on the modelling that we've seen, that is unlikely, it's probably going to be too cold over the winter to establish and stick around in sort of that Nelson area. That being said, there is the potential in the summer for it to establish for a short period when the water is warmer. That being said, one of the things moving forward that we're really keen to do is to kick off some research using a number of different universities and Crown Research Institutes, where we can actually understand both in the lab and preferably in the water as well, what the New Zealand tolerances and ecology is like in New Zealand. Unfortunately, that is still sort of in the works at the moment, but as soon as that starts, we'll definitely keep everybody updated. I think, Graham, you might have some additional questions or additional answers for that.
Oh, it's just a comment and following on from Barry's comment. I guess the experience would show that you take those climate envelope models with a grain of salt, that we know that a lot of invasive species can show quite different physiological tolerances outside their native range. And so while they're a good starting point, they're not certainly definitive. And those of us who are old enough, and Barry, I'll put you into this category too, will remember that when Undaria first turned up in New Zealand, the predictions were that it wouldn't be able to survive in Northland. Reality's been proved wrong. So I think we just, keep a watching brief on it around the country and keep a lookout for it.
Amy, I can see that you have a question.
Kia ora koutou, Amy Markello. I'm actually the response controller for the Caulerpa response alongside of Jess. And I actually just wanted to kind of build on Jess's and Graham's answers. So what Graham said was essentially just what I was going to build on and say, Barry, for your question about, could these two species of exotic Caulerpa make their way down south outside of kind of the risk zone that we're considering? And the answer is it's very unlikely, but as Graham has pointed out, never say never in the world of marine pests, because there's always more to kind of learn about how these organisms act. But we're very confident that the distribution is going to be limited up to the top islands, and that's why one of our kind of long-term strategies is going to be to do a bit more research on these two exotic Caulerpa in the New Zealand kind of context and how its ecology works, and to make sure that we can say with confidence that that distribution that we're predicting is correct.
Yeah, I guess if you're hedging your bets in the meantime, probably this is comments directed to MPI. There's been a lot of focus on pathway management, especially on hull biofouling. But it's just, it's an interesting example where we've got to think probably a bit more holistically beyond hull biofouling in terms of the potential mechanisms of spread.
Yeah, definitely. Yeah. Topside risk, I think, is sort of highlighted that there are multiple, as you say, sort of vectors for travel, whether that's for other species, biofouling or ballast water, but then also topside risk is really important to not get left out in that discussion. Any other questions?
I don't think so.
No. Okay, awesome. If you do have any other questions, please feel free to contact the Caulerpa liaison line. So you can just contact caulerpa@mpi.govt.nz, and we're happy to send that out to you guys if you've got any questions as well. Additionally, if there's any other information that you would like, if you are a member of a sort of, I don't know, a boat club or anything, and you'd like to get a number of pamphlets or anything, let us know. We're happy to send those to you as well. And again, the biggest thing for us is that we just want the word out to make sure that you clean your risk items, so your topside gear, and are able to just keep an eye out for Caulerpa from wherever you are, whether that is, as you say, Barry, top of the south, and it would be really great to know, or if you live in mainland Coromandel, for instance, and you think you've seen something, take a picture and send it through to us. We'd be greatly appreciative, just to sort of have some extra eyes and ears on the ground.
Thank you very much, Jess. I think with that we can finish, and you will all receive a link to this by email. It has been recorded, and you encourage you to share it with your colleagues or stakeholders or anyone that might benefit from it. Thank you.
Awesome. Also, if apologies that the videos didn't really work as planned, so if anyone does want to see those, we're happy to send you links to those as well.
Thank you.
Right,
Bye.
big thanks. Great presentation.
Thanks, guys.
Thanks all.